Okay, let's, thank you, Professor Lin. Let's move to the second invited talk. Our guest from Germany, Dr. Daniel Klingenfeld, is an expert on energy and climate policy issues. I guess you know Lindsay very well. Also, well, both of our guests are from PIK. It's the very important climate change research institute leading by, founded by Dr. Sean Huber. Right now, Daniel is working in the director's office, okay? In charge the scientific and the organizational support for the director, and also the dialogue with politics, business, and the society. And he's also a member of the governing board climate knowledge innovation community of European Institute of Innovation and Technology. It's a very long title. Anyway, so he's seriously involving many different opportunity in the community for the climate change issues. Okay, let's welcome Daniel.
Yeah, Professor, thank you very much for that kind introduction. Esteemed academicians, dear colleagues, ladies and gentlemen, thank you very much for hosting me here today. It's a pleasure to return to Taiwan now 4 years after our initial visit. And today I would like to talk about feasible decarbonization pathways for climate stabilization and according policies. And to kick us off, I would like to, in a sense, complement the graph that Professor Schellnhuber has showed on the temperature increase that we've witnessed since the beginning of industrialization, and actually launch an animation that will show you the driving force of that increase in temperature that we've witnessed and we are measuring. What you can see here actually is an animation that shows cumulative emissions from the combustion of coal, oil and gas, a process which has started in the middle of the 18th century in the United Kingdom with the invention of the steam engine and the use of coal power for industrial processes. And this process, in a sense, then has crossed the channel to other parts of Europe, also eastern part of the United States at the time starting to industrialize. And what you can see here in the animation is actually a consumption-based view on where emissions actually have led to, right? You see city center like London, the London area, becoming a big center of emissions just because of its population density, its energy needs, and its need for materials that are being used in this urban agglomeration. And as we now move into, well into the 20th century, you see in the acceleration of global usage of fossil fuels, with coal still being the dominant source. It actually was only up until the 1960s that oil became the #1 energy source globally. And you see the global effect, total emissions now, as we move into the 1980s, reaching 500 gigatons of CO2. And in fact, it only took us another just 30 years to cross the 1,000 gigaton figure. So big acceleration of emissions. And you see we've warmed the world by 1 degree centigrade, that has been mentioned. You see that picture is becoming increasingly scary, looking at the global total of emissions. And if we move forward and are not successful in bending the curve, and if we just remain on the business as usual pathway, we will see emissions rise and temperature go above 2 degrees Celsius well before the middle of the century, and rising, it was mentioned, to above 4 degrees and beyond by the year 2100. So this is, in a sense, a course of action we need to avoid. There was ample evidence in our keynote opening by Professor Schellnhuber as to why we must not remain on the path we're currently still on. And in that sense, I would like to reference in my talk key insights from the special report on 1.5 degrees by the IPCC. In this context, actually, I'd like to acknowledge my colleague Elmar Kriegler at our institute, one of the coordinating lead authors, who has given also input on the IPCC slides I'll be showing here. And in fact, we first, of course, need to understand global warming of 1.5 degrees Celsius. It has been mentioned since pre-industrial times, we've seen a temperature rise of about 1 degree Celsius, already seeing the consequences for people, for nature around the world, increasingly so. And at current rate, actually, we would reach that threshold of 1.5 degrees as early as in the next decade and a half. With the acceleration we're still on, with global emissions still being on an increasing path, we have seen some, let's say, some dampening around the years 2014, 15, 16, but basically a pickup recently, again, at some worrying rate. But the good news, in a sense, also is that we still have most of that development in our own hands, right? It is not just that past emissions will already commit us to 1.5, but we are getting closer, obviously, we know this, right? And so in order to gauge, let's say, where we are and where we need to go, I would like to talk about projected climate change impacts and associated risks. And there, in fact, really stress the difference of impacts between levels of warming of 1.5 degrees Celsius and 2 degrees Celsius. Well, if you just look by the year 2100 and look, for example, at sea level rise, the direct difference may look small, just maybe 10 centimeters, 20 centimeters in that range. But it could, of course, mean several meters of difference in sea level rise if the longer-term impacts are taken into account, such as the melting of the Greenland ice sheet, which, if completely gone, would add 7 meters to global sea level. And that, of course, would have dramatic impacts along the maps that Professor Schellnhuber had showed us before. So a dramatic increase, and really, in a sense, it's not an exaggeration to say that this would exceed, in all likelihood, our capacities for adaptation. So a big, big difference that this different temperature levels could make. Of course, we would also see quite a significant difference in terms of the exposure to extreme weather events around the globe. That is including extreme heat and rainfall. And there's another evidence in the report that water shortages could be, in a sense, up to 50% less if it were possible to stabilize global climate change at 1.5 as compared to 2. And finally, and that's also a staggering number, actually up to several 100 million fewer people would be exposed to climate-related risk that could push them into poverty already by 2050. So in a sense, if we just weigh this argument, what's at stake is really several decades of development, advances, of improving the human condition that could be reversed also just within the next few decades if temperature change just continued on the path we are still currently on. So many good arguments to take action as fast and as strongly as possible. And this is in fact the diagram, and the most recent diagram on the reasons for concern, where Professor Schellnhuber has shown us the evolution over the different assessment reports, starting with the third assessment report. So this is now the graph from the special report 1.5. And what you see there is, in fact, that's the current, more or less, warming that has been achieved. And you see here the range between 1.5 and 2 degrees Celsius. And you see these phase changes, especially looking at RFC1, the unique and threatened systems. And also, and I don't need to repeat, this argument was of course elaborated in our opening talk, the phase change from moderate to high risk levels concerning the large-scale singular events, the tipping elements in the Earth system. And here's just another animation of this basically global map, where science, and with key, of course, research by John Schellnhuber, has identified this variety of tipping elements where each and every one in itself is presenting an important risk and would have, in a sense, global implications if it were activated. But again, their connection is what makes the risk actually bigger, and where also you could have these positive feedback loops, which would, in a sense, not allow us to stabilize the climate, in fact, and we may see additional warming, even though we may be able to stabilize our climate system just by human emissions at 2 degrees centigrade. It's quite uncertain to what degree the natural feedbacks would add warming on top of that. Hence, what it actually means, climate stabilization, with the knowledge we have by now, is in fact really staying well below 2 degrees Celsius, in line with the Paris Agreement, and bolstering the case for doing everything that is possible by us to really keep that 1.5 limit, in fact. This is ultimately what climate stabilization means. I think that's fair to say from our current level of understanding. And now, this IPCC report is actually looking into pathways to do just that, looking into possibilities for us, for humans, to bend the curve of global emissions and to remain within that threshold. And here, In fact, I would like to show you another key output of the SR 1.5 report, which is looking at global emissions pathways and their characteristics here over the 21st century. So you see where we are here, more or less, still on this rising path of global emissions. The order are just around 40 gigatons per year. And you see like a corridor here. Like this is an ensemble of modeling results from global, more or less, energy economy system models that have investigated pathways for global emissions in line with a 1.5 degree centigrade target. So the good news at first is, well, okay, there could be a variety of ways to hold that line. And in fact, the IPCC has identified 3 exemplary or illustrative model pathways named P1 to P4 that, at least theoretically, from the modeling perspective, would allow us to hold that line. And in fact, these different scenarios, P1 to P4, are strikingly different in their appearance. And what you notice here in this graph is that the main difference basically lies in the magnitude of ultimately negative emissions, of extraction of CO2 from the atmosphere. Now, again, you are a research community here, so you're well aware of the fact that ultimately global warming will be determined in a quasi-linear way by cumulative emissions, meaning that if you delay mitigation, if you keep on emitting, you may make up for it by extracting CO2 in similar proportions later on. And basically this is the big hope in the P4 scenario, where in a sense the world is not really acting for the next decade or two, and then is coming on a very steep trajectory of decreasing emissions with huge negative emissions towards the middle and the rest of the century. So this is more or less the big bet in the scenario P4, whereas the scenarios P1 and P2 are betting or are actually implementing much stronger near-term action and then avoiding the need for such huge negative emissions. And now you can, or the IPCC has done this, compared in detail these different pathways, and of course you don't need to read the numbers from your seats, but basically the story is that of course you've got big differences in the energy systems development. The pace at which you build out renewable energies, the pace at which you phase out coal power globally. This is really reflected in quite some big difference among these scenarios. And that of course then has, as I mentioned, the implication on the need for carbon dioxide removal, which again then has implications on agriculture, on the land requirement for growing energy crops, then to be burned in thermal power plants with the CO2 then stored underground, right? That's the concept of bioenergy and carbon capture and storage. And then all these processes taken together give you emission pathways ultimately and linked to temperature reductions. Now, I say this orally to you. We are actually in the process of finalizing a study, colleagues at the Institute, looking at the feasibility of these negative emissions. And the outcome is that scenarios P4 for sure, but also P3 are not really implementable. Many constraints would be violated, and in fact, if we looked at P4, the requirement for land area to be used for bioenergy crops is more than 7 million square kilometers. 7 million square kilometers, which is, for comparison's sake, 20 times the size of Germany and about 200 times the size of Taiwan, right? So this is the theoretical assumption in that scenario, what would be required. And from our analysis, what colleagues are now just about to finalize, this is out of question. It's impossible, basically. And it would infringe on many other safeguards, ecology, agriculture, supply of more or less of food. And actually, to a lesser degree, but similarly, the scenario P3 still requiring close to 3 million square kilometers in that scenario concept is not really feasible. So what it comes down to, basically, is that we are, in a sense, left with a more realistic pathway, which is P2, and that pathway is actually requiring global emissions to decrease by about 50% from 2020 to 2030. So a halving of global emissions within the next decade would be required to ultimately get on a track to remain within 1.5 degrees centigrade warming. This is the outcome of further studies based on this IPCC report. And now you may say, this is squarely impossible. But the good news is it is not completely out of question that this may be possible. In fact, the IPCC report has also done a study on investment needs. It shows you to the left more or less a baseline, just continuing as we have, then an NDC projection That is a slight difference to business as usual. And then 2 scenarios on 2 degrees and 1.5. And I would like you to appreciate that the difference in annual investment needs between just baseline and 1.5 would be, in this estimate, if it were implemented soon, 830 billion US dollars per year. That may sound like a huge figure. It is a huge figure. But we've got a $50 trillion economy. So by all means, it is not an impossible task to redirect investments and to scale up the investments basically in renewables. That is, of course, right here this is this component that would be required to upscale it by a factor of 6 roughly by 2050 compared to 2015. And this is by no means out of an impossibility. We've learned, you've just started now implementing your policies just the first couple of years, how fast you were able to increase. I mean, a factor 10 of capacity expansion, and it's likely to continue. So anyway, this is the requirement here. And the last argument I'd like to make on this slide is that the difference between 2 degrees and 1.5 is actually a 12% increase in an annual investment needs. So it's, someone else said, it doesn't cost the world to save the planet. And I think this is underscored by these estimates here on investment needs to stay within 1.5 degrees. Now, what does that mean for climate policy? What does it mean actually for global climate policy? What does it mean for national climate policy and local one, of course? In fact, the carbon law was mentioned by Professor Schellenhuber, a study out of the year 2017 outlining a pathway for global decarbonization. At the time, including me, I thought, well, this is extremely ambitious. Is there a pathway to do it? But in fact, if you think about a feasible pathway for climate stabilization, this is corroborated, actually, by the findings of the IPCC. This is the pathway, this is the target space we should be getting on, we need to be getting on, to be, in a sense, able to stabilize the climate system. So that means that halving emissions every decade is supported, actually, by new research findings. Now, of course, in lockstep, it means that the NDC process, the process of setting nationally determined contributions, of determining your climate policies, ultimately, they need to go beyond bottom-up aggregation. Dr. Lin, I understand that you mentioned that the process of assigning sectoral targets, you take a grandfathering approach. Of course, you go, where are the emissions? And maybe we do 1%, 2% per year. But we have to be bolder, all of us, here and elsewhere. We need to also look at the more or less requirements for global decarbonization pathway, that is this halving. And if, in fact, the truth is even tougher for us in our technologically advanced countries. We need to move faster. So for the world to halve emissions in 1 decade, Germany and Taiwan would go beyond. That's the tough truth. That's what would be required for climate stabilization. But the good news in the end is that policy instruments are available. Transformation costs, I managed the investment requirements, are manageable, but time is of the essence. And again, we keep repeating this, but it is true. It's the longer we delay, the more unrealistic and the more costly it becomes. So I'm happy and don't have the time now to talk about the details of carbon pricing options. And the German government is debating this right now. In 9 days from now, on the 20th of September, we will have a policy package unveiled that will, in a sense, be an increase in ambition to Germany's climate policies. It will not be the last word in the debate, but it will be on carbon pricing in different sectors. I'm happy to talk maybe later in our debate in the afternoon about this. But long story short, so the policy instruments required to get on such a pathway are known. The research is fairly complete on this. We also know the implications of such policies. They need to be designed in a way that they are socially acceptable, that especially poorer households with still, let's say, who have difficulties in transitioning fast to low or no carbon energy sources need to be compensated to a certain degree. But we have the instruments ready to implement this. And if that is being done, in fact, you can realize a pathway that is in line with the carbon law, that is halving human carbon emissions, that is turning the land use sector from a source to a sink of carbon. That's, of course, very important. Land management practices. Professor Schellenberg closed with the point of preserving the forests around the world and managing those forests that are being used for timber production in a sustainable way. And, of course, to some degree, we may need still engineered CO2 sinks. That's still true, and from colleagues also I talked to, it is certainly an opportunity we should be exploring, and we probably need to activate over the century, but not to the proportions that some scenarios are promising us to be able to do so. So key remains short-term mitigation. And the last point, with this I would like to finish, is that actually the decarbonization pathway discussion really ultimately needs to be broadened into a sustainable development pathway analysis and implementation. We're all aware of the SDGs that were decided in the same year the Paris Agreement was adopted in 2015, and they give us this framework for a more comprehensive view on human development. And actually colleagues at our institute have been chiefly involved in, let's say, an effort called The World in 2050 that is actually looking into this broader target space and really trying to integrate planetary boundaries beyond climate into our analysis in order to formulate policies. And we've had the question on ecosystem implications, you know, on this solar PV if you do it more or less in the countryside. So integrating these different dimensions into policy planning will be key. And this is certainly an area of research we are still following through and still working on. But clearly we see the near-term action that is needed to embark on climate stabilization and the feasible pathways that I've just spoken to. So this is the messages I would like to leave you with, and I'm happy to take maybe one or two questions, and then looking also forward to the discussion in the afternoon. Thank you very much.
Thank you, Daniel. So we have time for questions, if you do have. Please, Professor Zhou.
Yeah, thank you, Daniel, for giving us a very charming talk. From Asian perspective, according to our research, in Asia, many countries are high carbon regime or high carbon economic bodies. Do you have any strategy to, combine to Asia's carbon reduction strategy? Because from the data of IPCC, we know that is a large scale of the knowledge and the information. The problem is how can we transfer this knowledge and information from the large scale, global scale, to the national scale, and to the urban scale, to the community scale. We know if we want to transfer or we want to speed up the decarbonization, we face a very big challenge because many countries are high carbon regime. Their ideology, their market, even their institution still remain the old mode. I think this is a very big challenge for us. Okay, thank you.
I absolutely realize, or we realize that challenge, right? And I think the quote that actually President Liao gave us this morning, quoting Bill Gates, I had not heard it before, but I find this actually a very fitting one, that you may overestimate what you can do in 1 year. You cannot probably change the world completely, but you often underestimate what you can do in 10 years, in a decade. So ultimately, it's a combination of factors. I mean, you mentioned different levels of action. This is key. So it's not just there's one pathway globally and it comes from somewhere and you do it per order and then everything will fall into place. No, it's not true. We know this. It's really a combination of gathering public support, public understanding. So education is really important, that people understand what's at stake. The talk that Professor Schellnhuber gave this morning, this is the full picture basically. And if everyone knew this, you would really see a much different public opinion on taking action. So talking about this, communicating is important. And actually the Fridays for Future movement, I can just say for Europe, for Germany, this has really changed the context. And the German climate cabinet, so this group of ministers who will take a decision in 9 days from today, they would probably not have come together, or certainly they will not take the decision they will not have taken the decision without this also pressure from young pupils, school children, students, because it's their future. Those will be those alive the longest throughout the 21st century and some beyond, to bear the consequences of the action taken or not taken today. So information is clearly key, and public acceptance. And then of course it's also initial successes. So you need to start from somewhere, right? And this will allow you, and hence also my previous question, if you see you are meeting your targets faster, hopefully you see the possibility to use that momentum and then to accelerate, in a sense, your targets or to improve your targets. this is, again, I mean, in Germany, in Europe, we have space for going faster. The coal exit, 2038. No, this is the very last point, but it will come earlier. There are many indicators why we have the space to move faster. So in a sense, and of course we could and maybe even in the afternoon, you ask the question again to all the panelists. It's an iterative process, right? You need to start from somewhere, you need to learn, but you need to be open to go as fast as you possibly can, And you will see that there will be an acceleration. Technologies are improving, economic opportunities. I mentioned to your vice president that the Gogoro scooters, I have to admit, I didn't know it was a Taiwanese company. Now I realize I see them in Berlin. Like it's all the e-scooters rentals in Berlin is Gogoro. So you have changed Germany in that sense. So you see, I mean, it's a process of discovery, and it needs also to be exciting, that people don't feel this to be as a threat, but as an opportunity.
Please go ahead.
I guess in the near future, we have to do a negative emission. Regarding to, you just talk about human carbon sinks. I would like to ask, to what extent the geological storage of sequestered CO2 play a role in the whole roadmap?
Okay, so I would have to pass on the question to the geologists in this room, but to my knowledge, we do not have a limit when it comes to the geological storage. The actual limit, and that's the point I was stressing, is where we get the biomass from, right? And this then has the implication on ecosystems and the cross impacts on the food system and on the agricultural system, basically. So this is where we've got the bottleneck, but to my knowledge at least, you know, if you liquefy CO2, if you store it deep enough where the pressure is high enough to keep it liquid, there is no shortage in the Earth's crust to absorb the numbers, even in the high scenarios. So the limitation is rather on the sustainability implications of, in a sense, extraction of biomass or of CO2 from the atmosphere, absorption, more or less using photosynthesis for this. But again, maybe the geologists would like to add to that.
Koyan is also a geologist.
Okay, so
we can talk about this
that was a trick question.
Yeah. There is some priorities, and I guess the situation different from place to place. Yeah. Okay. Any other question? Okay. Thank you, Daniel.
Thank you very much.